Good morning, everyone. Yeah, very good morning. Shall we begin the session? Yeah, today's topic is the looping. In the last class, we studied about the various statements that is used for the decision making. Now, today I'm going to talk about the looping. That is, what are the various loops that is used in the C language, in the procedure-oriented language. So, first of all, what is a looping? So, anything that occurs on a repetition basis, that is known as a looping. Yes, there are three kinds of loop that is available in the C statement. One is a for loop, one is a while loop, one is a do while loop. All these three loops. Okay. So there are three types of loop that is available using a while loop, using a for loop, and using a do while loop. This is the while, for, and do while loop that is available on this one or statements. Each of these statement has some description, some advantages, some disadvantages. Though it is first one is a while loop, so it is often the case in the programming that you want to do something with the fixed number of the variation. That is if the number of the variation is fixed, perhaps you have to calculate the procedure, that is how to adjust the data or how to do something with a fixed number of the times. Perhaps you want to calculate the ghost salaries of 10 different pages, or you want to convert the temperature from centigrade to the Fahrenheit for 15 different states. That is also possible with the while loop. So this is also available with the while loop. That is how to use the while loop that is used for the data acceptance. So the while loop is ideally situated for such the cases. Let us look at the simple example using a while loop that is available. So the flowchart shown below help to understand the operations of the while loop. This is a start, then count equals to 1. Now, if the count is less than equals to 3, so this starts with a 1. If it is less than equals to 3, then yes, input PNR, no, stop. So if with the input PNR, then SI, simple interest is calculated by P into N into R divided by 100, then print the SI. Then count equals to count plus 1. So this is starting with the count 1, then check the condition. It is going from the 1 to the 3, that is count is less than equals to 3. Then yes, it is correct. Then input the P and R, then SI equals to P into N into R divided by 100, then print the SI. Then count equals to count plus 1. Now this is a calculation of the simple interest for the three sets of the PNR. This is PNR or int P and count that is available. Then float R and the SI. Now three variables are used with this one for calculating the simple interest for the int type. One is a P, one in the N, one is a count. Then float R and SI. Then count equals to 1. Count equals to 1 in the sense waiting as a variable of the count equals to 1. Then while count is less than or equals to 3, printf enter the values of P, N, and R. So enter the values of the P, N, and R that is captured, that is scanned by using the scanf, that is stored in the memory by using the scanf, %t, because two are of the integer type, that is a P and N, and the float, that is a F, that is of the rate. That is, then calculate the simple interest, that is P into N into R divided by 100. That is P into N into R divided by 100. Then printf simple interest equals to rupees percentage F SI. So it is using as a percentage F, that is a float. Then SI variable is used for printing on the screen. So we are also using the printf screen. Then count equals to count plus 1. Count equals to count plus 1 means every time it is incremented by 1. Now these are the few sample runs. Enter the values of PNR. That is this one. This is a simple interest that is calculated via same formula, that is P into N into R divided by 100. Then again, this is the next example. This is the principal. Then this is the N, this is the R, then again this is the value. So the program executes after the while loop 3 times. So this execute for the 3 times 0, 1 and 2. That is available for the counting loop that is used with the while loop also. So as long as the condition remains true, all the statements within the body of the loop kept getting executed repeatedly. So every time it is executed repeatedly, and to begin with the variable count that is initialized to 1, and every time the simple interest logic is executed with the value of the count that is incremented by the 1. So every time it is incremented by the 1, every time it is used with the 1. And the variable C count is many a times known either a loop counter or a index variable. And the operations of the while loop is illustrated in the following figure. This is available in the following figure. This is the initialization, then this is the test. It is true, then body of the loop, then false, then stop, then there is a increment. Increment in the sense we have to increment the value, we have to decrement the value. This is either increment or decrement. That is not for sure that is only the increment, but it is also increment or the decrement. So there is a start, then there is the initialize, test, body of the loop, increment. If the test is true, then body of the loop. If the test is false, then there is a stop condition. Now, these are the tips and the traps. So, general form of the while loop is shown below. This is the initialize the loop counter. Then while test loop counter using the condition, do this and this, increment the loop count. This is the while loop that is available that keeps on getting executed till the condition remains true. And when the condition becomes false, the control passes to the first statement that follows the body of the while. And in place of the conditions there can be other valid expressions also, so that is used, or the expression evaluates, so the non-zero value the statement within the loop would get executed means they can be tested using the relational or the logical operator that is shown in the following examples. Then while I is less than equals to 10, j is greater than 10, and the j is less than 15. This is a while loop that is available that evaluates so the non-zero, zero, whatever the statement that is executing at the same time. And whatever the conditions that is been tested, that is used with the expression that evaluate to the non-zero condition that evaluate to the condition that is executed would get executed. And the conditions are tested that may be a relational or the logical operators also. So this is I is less than 10, so that means this is calculated as I that is less than equals to 10. So this starts with a 0 and ends with a 10. Then this is the end condition, that means it starts with a 0, this is greater than 10. Then 10 is also included over here, that starts with a 0 and ends with the 15. So 10 is also included and the 15 is also included. Then j is greater than 10, that means greater than 10, that means starts with the 11 and goes up to the b, that is either 15 or the 16. That means 16 to the 19. The statements within the loop may be a single line or the block of the statements. In first case, the parentheses are the optional. This is the optional. So while I is less than equals to 10, I equals to I plus 1. While I is less than equals to 10, I equals to I plus 1. As a result, the while must test a condition that will eventually become false. Otherwise, it will go up to the mark. It will go on executing, we can say, forever. And as a rule, while the condition is test or this test a condition that will eventually become false, otherwise the loop will be executed forever. This is the main function, then I equals to 1, I is less than 10, then print the values of the I. That means it is printed with the 1, 2, 3, 4, 10, 10. And this is an indefinite or the indefinite loop since I remain equals to the 1 forever. The correct form is this one. This is the incorrect form and this is the correct form. So instead of incrementing a loop counter, we can also decrement it and still manage to get the body of the loop executed over here repeatedly. This is shown also below over here. Now, this is what is the output of the following program. That means what is the output of this program. That is the same. That starts with the 1. So this is 1, then goes up to the 10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are more operators. There are a variety of operators which are frequently used with the while loop. So to illustrate their usage, let us consider a problem wherein the numbers are ranging from the 5 to 10 are printed on a screen. So this is one of the example in which the numbers are printed on a screen to perform this operation using while in the following ways, on the following manner. This is the main. There int I equals to 1 while I is less than equals to 10. Then printf percentage d, then I equals to I plus 1. This is the next example. This is I less than 10. Same. In this, j is incremented by the 10. That means every time j is incremented by with 10. Now, next is the for loop. So while is done. That means while, then there is a condition. Then the condition is true. Then whatever the statement we are executing, that is executed within the while. Then the next one is a for loop. For is again the same. That is too busy with the for. That is most probably the most popular looping instruction, and the for allows us to specify 3 things about a loop in a single line. First is setting a loop counter to initial value. That means first of all there is initialization value, that is I equals to 10, I equals to 2, whatever the initial value that is available. Then test the loop counter. That means the condition expression. For example, I is less than equals to 10. Yes, this is a loop counter, or we can say the expression or the condition. Then incrementing the value of the loop counter each time the program segment within the loop has been executing. So increment the loop counter or the values of the loop counter, whatever the loop counter that is available. So each time it is incremented with the program segment within the loop that has been executed. And this is the example. This is how we can say the syntax. So for initialize counter, then there is a semicolon, then there is a test counter. Again there is a semicolon, then there is an increment counter or the decrement counter. So first of all there is an initialization. After the initialization there is a condition. Then after the condition there is an increment or decrement. This is the loop control structure. Count equals to 1, count equals to count plus 1. Then this is the flow chart that shows how it works, we can say. Then first one is the start, that is represented. Then there is a initialize. After the initialization there is a test. Test condition means that is a loop counter. For example, I'm taking the example of this same example, that is I is less than equals to 10. So this is available within this diamond box. And if the condition is true, then only the body of the loop is executed. But if the condition is false, that is not executed, we can say that goes to the stop value. And if it is executed, then increment the values also for the next looping or for the next value. This is the main function. Then int I for I equals to 1, I is less than equals to 10, I equals to I plus 1, that is I plus plus. So we can write I plus plus also, or either I equals to I plus 1. So this is printf percentage t and I. Joseph, you want to say something? Hi Joseph, you want to say something?
Yeah, good afternoon, sir.
Yeah, good afternoon.
Well done, sir.
Yes,
Happy New Month.
Yeah, same to you. So tell me, Joseph.
Yes, sir. I was checking our assignments.
Which assignment?
I'm checking all through the assignments,
No.
and I discovered that.
Which assignment? It's which module assignment? I mean to say computer system assignment, procedure oriented assignment, which assignment?
No, no, no. I'm not talking about a specific assignment. I just want
Okay.
to ask a general question, sir.
Okay, tell me.
Yes, I discovered that we have 4 semesters, and each semester has 4 modules.
Yes.
Now, if we are through with the assignment of the first module, is it not supposed to, of the first semester, is it not supposed to go to Edexcel and give us a result per semester?
No, 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 that is not possible because the result is compiled after compiling all the semester. That is not possible that you need a result for the one semester. That is not possible.
So it is for all the semester
Yeah, there are
once.
total 16 module that is divided into 4 parts. I agree, but the result is the compilation of all the 16 modules.
Okay, sir.
One more question, Joseph, from my side. Have you got all the assignments, all the 16 assignments, or anything left?
No. We have 2 left.
Two left. Which what are the assignment that is left over?
Yes. Let me quickly check, sir.
Yeah, you because according to me, I have given all the 16 assignments to you. So please check it out.
You have sent to us 14 assignments,
No, no, no. What are the two assignment that
14
is?
modules.
What are the two assignment that is missed out?
I will need to check